Aluminum extrusion is a process by which aluminum alloy material is forced through a die with a specific cross-sectional profile. Toothpaste coming out of a tube. Aluminum extrusion can be likened to squeezing toothpaste from a tube. A powerful ram pushes the aluminum through the die, and it emerges from the die opening. When it does, it comes out in the same shape as the die and is pulled out along a run-out table. At a fundamental level, the process of aluminum extrusion is relatively simple to understand. The force applied can be likened to the force you apply when squeezing a tube of toothpaste with your fingers. As you squeeze, the toothpaste emerges in the shape of the tube's opening. The opening of the toothpaste tube essentially serves the same function as an extrusion die. Since the opening is a solid circle, the toothpaste will come out as a long, solid extrusion. Below, you can see examples of some of the most commonly extruded shapes: angles, channels, and round tubes. On top are the drawings used to create the Ds, and on the bottom are renderings of what the finished aluminum profiles will look like. The shapes we see above are all relatively simple, but the extrusion process also allows for the creation of shapes that are much more complex. What kinds of shapes can be extruded? There are three main categories of extruded shapes: solid, with no enclosed voids or openings, i.e. a rod, beam, or angle; hollow, with one or more voids, i.e. semi-hollow, with a partially enclosed void, i.e. related, aluminum extrusion dies. This is what designers should know. Extrusion has innumerable applications across many different industries, including the architectural, automotive, electronics, aerospace, energy, and other industries. Below are some examples of more complex shapes that were designed for the architectural industry. What you may notice about the first and second images is that they are both made up of not just one, but multiple extrusions. The designers created systems of multiple interlocking shapes. The black profile in the middle is actually a polyamide thermal break, used for insulation, and the gray profiles are aluminum. You can see the details by clicking the images to zoom in and then noting the color difference between the profiles. Perhaps now the basics of aluminum extrusion are clear. So let's dive deeper into the details of the process. The aluminum extrusion process in 10 steps. Video clips. We've divided the extrusion process into 10 steps. Let's take a look at what they are. Step 1. The extrusion die is prepared and moved to the extrusion press. First, a round-shaped die is machined from 13 steel. Or, if one is already available, it is pulled from a warehouse like the one you see here. Before extrusion, the die must be preheated to between 400 to 5,500 degrees Celsius to help maximize its life and ensure even metal flow. Once the die has been preheated, it can be loaded into the extrusion press. Step 2. An aluminum millet is preheated before extrusion. Next, a solid cylindrical block of aluminum alloy, called a billet, is cut from a longer log of alloy material. It is preheated in an oven, like this one, to between 400 to 500 degrees Celsius. This makes it malleable enough for the extrusion process, but not molten. Step 3. The billet is transferred to the extrusion press. Once the billet has been preheated, it is transferred mechanically to the extrusion press. Before it is loaded onto the press, a lubricant or release agent is applied to it. The release agent is also applied to the extrusion ram to prevent the billet and ram from sticking together. Step 4. The ram pushes the billet material into the container. Now, the malleable billet is loaded into the extrusion press, where the hydraulic ram applies up to 15,000 tons of pressure to it. As the ram applies pressure, the billet material is pushed into the container of the extrusion press. The material expands to fill the walls of the container. Step 5. The extruded material emerges through the die. As the alloy material fills the container, it is now being pressed up against the extrusion die. With continual pressure being applied to it, the aluminum material has nowhere to go except out through the opening, S, in the die. It emerges from the DA's opening in the shape of a fully formed profile. Step 06. Extrusions are guided along the runout table and quenched. After emerging, the extrusion is gripped by a puller, like the one you see here, which guides it along the runout table at a speed that matches its exit from the press. As it moves along the runout table, the profile is quenched, or uniformly cooled by a water bath or by fans above the table. Step 7. Extrusions are sheared to table length. Once an extrusion reaches its full table length, it is sheared by a hot saw to separate it from the extrusion process. At every step of the process, temperature plays an important role. Although the extrusion was quenched after exiting the press, it has not yet fully cooled. Step 8. Extrusions are cooled to room temperature. After shearing, table-length extrusions are mechanically transferred from the runout table to a cooling table, like the one you see here. The profiles will remain there until they reach room temperature. Once they do, they will need to be stretched. Step 9. Extrusions are moved to the stretcher and stretched into alignment. Some natural twisting has occurred in the profiles, and this needs to be corrected. To correct this, they are moved to a stretcher. Each profile is mechanically gripped on both ends and pulled until it is fully straight and has been brought into specification. Step 10. Extrusions are moved to the finish saw and cut to length. With the table-length extrusions now straight and fully hardened, they are transferred to the saw table. Here, they are sawed to pre-specified lengths, generally between 8 and 1 feet long. At this point, the properties of the extrusions match the to-4 temper. After sawing, they can be moved to an aging oven to be aged to the 5 or 6 temper. What happens next? Heat treatment, finishing, and fabrication. Once extrusion is completed, profiles can be heat treated to enhance their properties. Then, after heat treatment, they can receive various surface finishes to enhance their appearance and corrosion protection. They can also undergo fabrication operations to bring them to their final dimensions. Heat treatment. Improving mechanical properties. Alloys in the 2000, 6000, and 7000 series can be heat treated to enhance their ultimate tensile strength and yield stress. To achieve these enhancements, profiles are put into ovens where their aging process is accelerated and they are brought to the 5 or 6 tempers. How do their properties change? As an example, untreated 6061 aluminum to-4 has a tensile strength of 241 MPe, 35,000 psi. Heat treated 6060. 1 aluminum 6 has a tensile strength of 310 Me, 45,000